Namaste, and here it's me Rohan Bajankar, and in this video we will be dealing with EViews. And our contents of this video are: we will first deal with about EViews and its general overview, and we will learn about inputting data, making graphs, and finally we will jump into the few tests that we perform in the time series data. Here, as we know that EViews is basically meant for the time series analysis. So in this whole tutorial, we will be only dealing with time series data such as GDP or the other form of data that are of time series nature, and followed by the unit root test, we will be dealing with regression analysis and the diagnostic tests. So for it, let's open EViews, and it's version 9 in my PC. And here, as we open the EViews, we will have a dialog box, and in this box there are three parts, that is of EViews work files, support and recent. Since I have worked in these files previously, it's showing the recent files, but if you haven't worked in EViews, then this section will be blank or you will not have any recent files. So now, assuming that you have not worked in the EViews till now, let's create a new EViews file. And here also there are three options. You can create a new file, you can open a EViews document, or open a foreign file such as Excel. So now, without delay, let's create a new EViews work file. And as you click on it, again a box will appear. First is work file structure type, second is date specification, and it's the start and the end date. And this is optional as it has been said by EViews, and these three are most important. And here the upper part is the most important, and without filling this you cannot proceed further in EViews. So now let's check these options. In dated regular frequency, it is the most common format, and you can also select the undated if your data is undated, but in time series it's basically a dated one. Or you can also use the balanced panel data, means that if your data is both the cross-sectional and a time series, then you can use panel data, but in my case it's time series only, so I will choose the second option. And for frequency, you can choose annual, semi-annual, quarterly, monthly, or daily. So in my case it is annual, so I will choose annual, and in your case it may be quarterly or monthly or any of the format that your data is in. You can choose from this list below. And my start year is 1975, and the end date is 2020. End date is 2020. This is my time series data, and the start date and end date may differ from mine in your case, so you can change this date as per your requirement. And I will click on OK. So finally a box will appear again, and now in this case you can see that there is range, and here is sample, and this range means that the range you have given, and the sample means that the year you will choose to make an analysis, to carry out the analysis. And you can change the sample by clicking on it, such as I will click on it, then if I double click on it, then the box will appear again, and here it says that sample added sample all. It means that the whole range is taken as sample, but you can also change the sample range if you want. So this is the general overview of the EViews, and let's check the menu bar. And here is the menu bar, and let's check it one by one. First is file. If I click on file, then here is new, open, save, save as, and so on, import, export, and so on. And now in the edit, there is copy and paste, and it is not so much important. And the object, and we don't use these menu command right now. And we don't use these commands right now. So for our reference, we will only use the quick command for now. And in the quick command, we will basically use the estimate equation, estimate bar, and so on. And now let's learn to import the data. And here are and you can import data from this menu bar also. You can go here, file, click on file, you can click on import, and you can import from file. Let's click on it, and you need to choose the data, and the box will appear, and we'll click on next. I think the whole data is okay for me right now, and the and you must have a look over this part, the header line. It's of first one. This means that the first line is header, and if I click on this 2, then it will change. So I'll not change this right now. It's okay for me. Click on next, and the whole series is okay for me, whole data is okay for me, and click on finish. And link object release alpha objects to external source, and you can click on yes or no. Then and for me, I will click on no right now, but if you click on yes, then if the data in the Excel file is changed, then the whole analysis will also change. In this case, let's click on yes for now. Finally, my data are imported, and you can also import this data from the next method. Let's delete it for a while. I'll delete it, yes to all, and I will open my Excel file. Let's open the Excel file. Oh, sorry. Since I have linked it, I was unable to open the Excel file. And the next method to import is, you can open the Excel file, you can copy this data from the Excel itself. Let's right click on it, and let's go to EViews, and let's click on paste. You can do it simply by copying the data from Excel and pasting it on the EViews. Let's click on next, and the new thing is, the EViews will ask you to state the start date. It's 1975, and EViews will automatically populate this field, and let's click on finish. I don't want to link it, so I will click on no. So we have finally imported the data from two methods. You can do it from the file and import from file, or you can just copy and paste from, we can just copy from here, from your Excel file, and go to EViews and paste on it. These are the two methods, and you can use any of these methods to import your data. And now, for our analysis, we must first perform the data into log. That means we must first convert the data into log for analysis, or you can also do so because doing log will uh, provide us with the great advantages, such as the data will be smoothened, and the second most important feature is we can find out the elasticity. So now let's do the log transformation of the data, and you can do it simply by generating a new variable gnr ln underscore cpi equals to log. I think it will take log log, not ln. If I click into it, enter, then the new variable is formed, ln cpi. And you can also do it in excel and bring back to the EViews, such as you can do it here in a very easy fashion, that is ln and do real GDP, and similarly you will drag it to up to this point. Let's delete it and simply drag it down. Simply name this as ln. We must name it as real GDP. I will drag it here. Now my series is ready. It's very easy. And now let's delete it because it will duplicate in views, and let's paste it here, and let's click next, and the similar process is here. Try it will populate it automatically, and let's finish. No. So I have done it from Excel, and you can also do it manually from this part, writing this formula. So now let's perform the unit root test. Now we will go to the unit root test. Or first of all, we can have a look over its graph. So now let's click on the LNCPI. Let's double click on it. The spreadsheet will open in our EViews, and in this point we will click on view, and let's click on graph. Let's view it graph, and the box will appear, and the graph type, it's line and symbol, not bar, not spikes, not area. We'll click on OK. The graph is formed automatically by EViews, and you can change the name of or the you can change the header name or the title of the graph by simply double clicking on it. And if I say that log of consumer price index, if I click on OK, then this will change, and you can copy it and paste it wherever you want to show this graph. And secondly, we can also check its correlogram. And the correlogram means that it will show the autocorrelation function and partial autocorrelation function. And let's do it in the labels. And from this also we can say that and from this also we can confirm that the data is stationary or not. That is, if our autocorrelation function is declining over a period of time. Declining means it is being less and less over the period of time, then we can say that the data is not stationary. And following it, let's move towards the unit root test. Let's test our let's test the result of the correlogram from the formal test, and it's the ADF test, and you can choose any of these tests from here, but the most common use is ADF test and Phillips test. You can do the both of the test or any one. The result will be almost similar. And let's click on the lag selection as the automatic selection, because EViews will do it automatically. And let's test that, and this is the most important portion in it. Include in the test equation, there are three options here. First is intercept, second is trend and intercept, third is none. And in this point I will be using trend and intercept. This is because we have seen the graph here, and let's see it again. Let's see the graph again. Let's click on OK, and we can see that what's clear is that here is intercept here in this graph, and the line is having a trend, that is, it is increasing year by year, means that there is a trend in the data. So we will use intercept and trend in this case. So now let's go to unit to test, and let's click OK. And we must see this probability value. If it's less than 0.05, then the data is stationary, else the data is non-stationary. And the null hypothesis is LNCPI has a unit root. It has a unit root, means that the data is non-stationary, and the same result has been confirmed by the graph of correlogram. So this is the portion of the unit root test, and we will carry out the similar analysis. We'll carry out the similar analysis in the following parts, or in the following variables. And let's talk about the correlogram, or the second part of the correlogram. Let's click on view and correlogram, and let's click on OK. So now let's have a glance of a correlogram. We have talked about this function, and this is called ACF function, or the autocorrelation function, and this is called PACF function, partial autocorrelation function. As the autocorrelation function decays over a period of time, then it is said that the variable is non-stationary, and this is also called MA process. MA means moving average process. And the partial autocorrelation function provides us with the AR process, means that autoregressive process, and the function is of autoregressive of order 1. This means that if we use the difference of it, then the data will turn into the stationary one. That means that DLNCPI means that difference of LNCPI will be stationary process, as it's confirmed by the correlogram. So now let's have a look over the view, and let's go on unit root test. Let's move on the unit root test, and let's click on first difference, means that difference of the LNCPI. And since the difference will be stationary, there will not be any intercept, any trend. So we'll only click on intercept, and we'll click OK. So now we can clearly see that the probability is less than 0.05, and the data is stationary, means that the AR1 process says that if the data is in this first difference, then the data will be stationary. So now let's have its correlogram in the first difference. View, correlogram, and let's click on first difference, and let's click OK. So we can see that finally our data is stationary, as it's confirmed by the autocorrelation function, means that the autocorrelation means that the autocorrelation function is within this band, and the function is sometimes positive, sometimes negative, as shown by the graph that is turning right and sometimes left. And this is the same case for partial correlation or partial autocorrelation. So our data is free from the non-stationary process, and we will do same for other variables and carry out the regression. So now we will carry out regression in our next video. Thank you.